Hello, everyone. This is Elisa Baum. I'm Percona's Director of Product Marketing. We'll begin in a moment, but first I'd like to conduct housekeeping. Could you please raise your hand using the hand icon located in the GoToWebinar control panel to let me know if you can hear me okay? Let me see here. Yes, thank you, audience. I see your hands. Next, during this webinar, you will be on mute. Should you have any questions during the discussion, please go ahead and enter them in the questions field within the control panel. At the end of the webinar, I'll take time to answer as many questions as possible, and those that aren't addressed will be answered in a future follow-up blog entry on Percona's performance blog. In addition, everyone that has registered for this webinar will get a link to the recording and the slides within 48 hours. So if you have to pop off, no fear. I will make sure that you get a link to the recording as well as the slides. I'd like to thank you today for attending our webinar, Advanced Query Tuning in MySQL 5.6 and 5.7. It's being presented by Percona Principal Consultant Alexander Rubin. And with that, I'll turn the floor over to Alex. Go ahead, Alex.
Hello, everyone. My name is Alexander Rubin, and today I will talk about advanced MySQL query tuning, and this will cover MySQL 5.6 and some features of MySQL 5.7. So let me introduce myself. My name is Alexander Rubin, and I've been working with MySQL for over 10 years. I started at MySQL AB 2006, and then worked through the Sun Microsystems and then Oracle doing MySQL consulting. And I joined Percona 2 years ago. So I am a principal architect, principal consultant at Percona, and my job is to help customers with their MySQL installations and performance issues. So today's agenda, we will talk about the queries. And we will talk about the queries and how to optimize them. And those will cover the queries that you will usually find in MySQL Flow query log. Those involve group by and order by and distinct queries. Now, I have also included the new feature in MySQL 5.7. MySQL 5.7 is not released yet, but it has a very interesting feature called calculated fields, and we will talk about that today. So let's start. I will start with a very basic thing and explain how indexes works in MySQL, how explain works in MySQL. And if you think that this is you already know all that, just stay with me and we will cover more advanced things in a couple slides. So let's start. To start with, I use this example table, which is called city. It's a part of the MySQL test database called World Database, and you can download it from MySQL website. So this is the basic table, and it has a primary key in it, and also have a secondary key on the country code. So here's what we have. MySQL will use one best index for the query. And this is obvious, and this is how explain looks like here. So in this example, if you specify where ID equals 1, then MySQL will use a primary key. If you specify country code equals USA, then MySQL will use a country code. This is obvious. Now, what MySQL can do is it can use a leftmost part of the combined index. So in MySQL, you can create a combined index and specify multiple fields in it. In this particular example, I create a combined key on the country code, district, and population. And I name it comp. This doesn't mean anything. It's just a name to distinguish from other keys. So let's see how it works. If we specify the country code, then MySQL can use the first field out of the combined index, a leftmost part of the combined index. How do we know that? We know it from looking at the explain example and see the key length. Here the key length is 3. That means that MySQL is using the first field. So how do we know that again? We can do a basic math. Key length will specify the total size in bytes of all index parts that MySQL will use. Again, the index is on country code, district, and population. And the country code is declared as a char 3. So by looking at the key length 3, we see that the first field out of our 3 fields index is being used. Now the next example is we use country code and district. And again, MySQL will use the 2 leftmost fields out of our combined index. We look at the key length and we see that the key length says 23. Country code is 3 characters, 3 bytes. District is 20 characters, 20 bytes. And the total is 23. So we know that MySQL will use the 2 leftmost fields out of our index. Now, 3 leftmost fields is obviously the same thing. Now we can do the same math. Key length is 27, so it's all the fields in the combined key. So that looks good. Now, if you're a little bit tired of doing this math, what you can do is you can use a new feature in MySQL 5.6, which use the JSON format. You can add this to your explain query and add this format equal JSON, and you will see that MySQL will will show you which fields it will use out of the index, so you don't have to calculate the length. Now, in this particular example, MySQL will not be able to use a combined index. Why? Because it's a not leftmost part. The country code is missing from this query example. So MySQL explain output will show that there's no key used and the type is all, meaning that it's doing a full table scan. All right, so this is combined indexes in MySQL. Now MySQL also has another feature which called covered index. Now what covered index? Covered index is an index which will cover all fields in a query. In this particular example, we create an index on country code, district, population. Those are the fields in the where clause, but we also add a name field. And this is what we select. That would make it a covered index. Now here's the rule of thumb. If you want to create a really covered index, what you will need to do is to use all the fields in the query in this particular order. So first we'll need to add all the fields that are part of the where clause. Then we will need to add fields in the group by, order by, and there is no group by and order by here. And then finally we will need to add select part. Here we add name. Now how do we know that MySQL will use the covered key, and what does it mean? So we can do, again, we can do explain output. And here's what's different here. We see using index. If we see using index in the extra field of the explain output, that means that MySQL is using a covered index. Now the major benefit of that is that MySQL will only use an index file. It will not go to the data file. So it only needs to read the index to satisfy the whole query. And usually it is much faster. Now we know how MySQL use indexes, what kind of indexes we have in MySQL. We can go forward to the more advanced topics. So let's start with calculated expressions in MySQL queries. I will demonstrate this by using the air traffic statistics table. The air traffic statistics data is available for download free of charge from the government website. And the air traffic statistics covers and contains information about all the flights in the United States, including delays and cancellations and stuff like that for about 20 years. So I have created this example table. I name it on time. And there are lots of fields in it. This is a very wide table. I removed it for better visibility. So this table has flight date, which is declared as a date field. It also has a primary key, and it also has a secondary key on the flight date. So let's talk about this example. Let's say I want to find all flights in 2013 and group by airline. So the brute force approach, the first approach that we take, is we can extract a year out of the flight date using MySQL function called year. So we do that, we do the explain on the query, and we see that MySQL is not using any index. It's doing a full table scan, and this is really slow. It's 1 minute 49 seconds in my test case. It also creates a temporary table and a file sort, and we will talk about that in the next slides. So why doesn't it use an index? We have an index on the flight date, but we also have a year function. So it's a calculated expression, and MySQL will not be able to use an index in this particular condition. So as a general rule, every time you use a calculated expression, a function, or anything else on the field itself, MySQL will not be able to use an index. Now, how do we fix that? Well, for year, it's straightforward. We can convert this expression to a range expression. So instead of doing flight date and extract a year from the flight date, we can use a between. So in this case, we are looking for the range of the 1 year, and we can use a between clause in MySQL. As you can see, that is much faster. And range condition will allow MySQL to use an index on the flight date. And this is almost 10x faster. It still has to create a temporary table and do a file sort, but at least it is not doing the full table scan. So the flight date and year is straightforward. But what about more complex scenario? Let's say that I'm only interested in the flights on Sunday. Again, this is across 20 years, but I want to only find the flights that departs on Sunday. So I do this day of week and extract the day of week out of the flight date and filter. Again, day of week uses MySQL calculated expression, and MySQL will not be able to use an index in this case. And again, this is slow. This is 1 minute. It's even slower than extracting a year. So what do we do in this case? The standard solution is to store an additional field. What we do here is actually we materialize this field, and we store it in addition to our fields in a table. So we add this field flight day of week, but we also need to maintain it. We need to update it every time you insert rows into this table. And if you update the table, this needs to be changed as well. So we can obviously change the application, but sometimes it's hard to find a piece of code that maintains this table. What we can do is to use triggers. In this particular example, I created a trigger on the insert. So for every insert into this table, what will happen is that MySQL will extract the day of week and store the day of week, a materialized day of week in the table. The disadvantage of this approach is that it may be slower on insert, especially for the bulk inserts, for multi-row inserts or insert select. MySQL will have to process this trigger on every row, so it will be slower, but it will work. But what if we will be able to index a field but don't store it? That feature is called a virtual column or generated columns, and is available in MySQL 5.7 labs release. That is really cool feature and really useful for many applications. So what we do here is we declare an additional column, and we declare it as a generated always. And we specify a function. Instead of day of week, we can use anything else. But we specify a virtual column, so it will not be stored. But we can also create an index on these virtual columns, and the index will be materialized. So we can create a virtual column with a function and index it. And that is really good for both performance and storage. So what I did is I did a quick test. I wanted to compare the performance of the triggers version and the virtual columns version. And it looks like the virtual columns version is much faster. This example actually demonstrates the bulk insert speed. And the reason why the virtual columns is much faster on load compared to triggers is that a trigger will process this function, will process this trigger text, trigger function for every row. And the virtual columns are much more optimized and will be able to do much more bulk operations inside. So the load is much faster, but it also will be able to use an index. So when we do this query again on the virtual column and specify flight day of week equals 7, group by carrier, we will see that it's actually using an index. And again, we are using an index on something that is not materialized. So it will not store it in the table, but the index will be stored. That's a really good feature. There is one limitation of that right now in MySQL 5.7. You cannot mix a generated column and non-generated column. To optimize the query, we actually will benefit a lot from the combined index. We want to create an index on the day of week and carrier to avoid creation of the temporary table. And we'll talk about that in a couple slides. But it's not available in this labs release of MySQL 5.7. The workaround for that is we can create another dummy virtual column on our carrier. In this case, I create carrier virtual. I declare it as the same char2, and I don't use any function on top of that. Because we have two virtual columns, we can mix them in one index. So that works. So as you can see here, that is very good for the performance because it's also avoid creating a temporary table, and we see this using index here. So it only uses an index. It will not go to the data file, which is also very good in case of the very wide table. Originally, this table was really wide with 150 fields, and if we are only using an index out of that, that will be very performant. So let's talk about our next topic is about the complex slow queries. Those are usual suspects. Those queries that you will usually find in your MySQL slow query log. And those queries will usually contain group by, order by, or select distinct. And they will usually create a temporary table or doing so-called file sort. So let's start. Let's start with the group by queries. So for the group by and simple example, I use the same city table that I used in the beginning. So let's say that we want to know how many cities do we have in each country. So we do this very simple example and we group by country code. Originally, this table doesn't have any indexes, and as we can see, the explain shows that it's doing using temporary. And we know already that the temporary tables are slow, but let's look into more details. So let's talk about the theory of the temporary tables, how MySQL creates temporary table and how does it use it. So MySQL will have to create a temporary table when a query uses group by or range by plus order by some other expressions like distinct plus ranges. There are two types of temporary tables in MySQL: memory temporary tables and on-disk temporary tables. So how MySQL will decide which temporary table to use? First of all, MySQL will try to create temporary table in memory. And there are two MySQL configuration variables, TMP table size and max heap table size. In this example, in this configuration variable name, heap means memory. So TMP table size sets the maximum size for memory temporary tables, and max heap table size sets the maximum size for the memory engine. MySQL supports the memory engine. So if MySQL temporary table that needs to be created will be larger or will grow larger than the TMP table size or max heap table size, MySQL will convert this to MyISAM temporary table on disk. It will do it by itself. Now in MySQL 5.7, the temporary tables will be on disk in InnoDB format by default. And there are some advantages and disadvantages of that. Now, another limitation of those temporary tables and storage is that memory engine doesn't support blobs or text. So if you are selecting a blob field or you are selecting a text field, it doesn't apply to varchars. Only if a field is declared as a blob or text and you do a group by, then MySQL create on-disk temporary table right away. Same thing if you're doing something like select concat and the result string will be larger than 512 characters. So MySQL will create on-disk temporary table MyISAM format right away. So let's talk about the practice and temporary table optimizations. How do we clean them up? I did this example and did this benchmark a while ago, and again I used the air traffic statistics table. This table is for flights in 2012. This table has about 6 million rows and approximately 2 gigabytes inside. So it's not that large, but it's good as an example. And here you can see the website URL where you can download this information and do your own test if you wish. So let's talk about this example. Let's say we want to find the maximum delay for flights on Sunday, and we want to group by airline. Right? So this is very simple what we did already. Now, I already materialized this field. So the table that I was working with already have the day of week, and this day of week is populated as well. Good. So we'll not talk about that. But here's the query, and we do select max of depth delay minutes is our delay in minutes, and we filter out by day of week and we group by carrier. Carrier is our airline. So here's what we have. Originally, there's no good index. Day of week is not indexed. Carrier is not indexed. And MySQL will have to go through this 4 million rows and create a temporary table. Full table scan, temporary table, it's obviously very slow. So how do we fix that? Well, first of all, we need to fix the full table scan, and we add an index on day of week. That's what we already did. So in this case, it's better. It's using the index on day of week, but it still creates a temporary table. So how do we fix the temporary table part? Now, in this case, we can create a covered index. As we talked about before, covered index is the index that cover all the fields in our query. In this case, we have day of week, carrier, and dep delay minutes. So in this case, what we see is MySQL will be able to use an index, a covered index, to avoid creating a temporary table. This algorithm is also called tight index scan. So that is much faster. This is the best approach. There's no temporary table, and MySQL will only use an index. So it will not go through all those 150 fields that is available in this table. Now, there are some cases where the covered index are not very good. And it is where you specify a range. For example, if you are only interested in day of weeks more than 3 and group by carrier, you also want to group by day of week. In this case, MySQL will not be able to use an index at full extent. Now, it will use the leftmost part of this index. It will use day of week part of this table, but it will still have to create a temporary table and a file sort. Now, it also shows the using index, so it is good in this regard because it will use the index, covered index to satisfy the query, but in addition to that, it will have to create a temporary and a file sort. So there's no really good approach to fix that, but there is one hack that we can potentially use if our field has a very limited amount of values. In our case, day of week only have 7 distinct values. So we can convert this query to a union. In this particular case, we specify where day of week equals 3 group by carrier. We can remove day of week actually from this group by. So we can convert it to the number of queries and union them together. In this case, MySQL will be able to use an index on each of those queries. So here's how it works. It uses a covered index, and we see there is no temporary table, there is no file sort on each individual queries inside of the union. Now, to satisfy the result set, union will have to create a very small temporary table, but usually it's not an issue. You can also do a union all, but MySQL will still have to create a temporary table to store the intermediate result before the union. So this hack can be potentially useful if you're doing some specific fields and your field that you're filtering on only have a limited number of values. Another algorithm that you can potentially use and is available in MySQL is called loose index scan. Loose index scan is actually even better, even faster compared to the tight index scan. Loose index scan considers only a fraction of the keys in an index, but it has some limitations. First of all, the query needs to be over a single table. Then the group by column should be leftmost prefix of the index. We'll see it in a second. And last thing is that there are only a few aggregate functions are supported, currently minimum and maximum on the same column. So here's the example. I create this new key and I name it loose index key. Again, the name doesn't mean anything here. I just want to distinguish it from our covered index. Now, as you can see, I start from group by part. So it's another order. I start with a group by, and then I cover the where clause, and then finally I cover the select part of the query. Here's what we have here. When I do explain, I see that our key is being used. Lose index scan is used here. But what I also see is using index for group by. If you see using index for group by, it means that our query is using this lose index scan. And it's very fast. Also, the good news is in this case, range will work. In our cases, to make range work, we have to convert it to the union. Now, you don't have to do that. If you only use a max or min or some other set of functions that are supported for the lose index scan, that may be a good example. That may be a good strategy to optimize your queries with the temporary tables. And then finally, I did this test against the on-time 2012 table. The index size in this case was only 210 megabytes, but if you can imagine, this on-time statistics covers 20 years, so you can multiply that by 20. So I created two indexes, lose index scan and the covered index, and I did this benchmark. So this query works really fast. It is significantly faster than the tight index scan. So it returns in 0 seconds. Actually, to profile it, we'll need to enable the slow query log with a microseconds precision, or we can use some other techniques in 5.6, for example, performance schema. But here's the example, and I get the actual result, the timing from the lose index scan in milliseconds. So as you can see, lose index scan in this case is much faster. Tight index scan is also okay compared to the temporary table. So the temporary table and just a single field index result is 1.4 seconds. Tight index scan is 0.4, and loose index scan is sub-second performance. Now, there are lots of cases, unfortunately, where the loose index scan is not supported. For example, if you do average plus the group by, loose index scan is not supported. If you do explain on that, then we will see that it's using covered key here instead of our loose index scan key, and it's using temporary using file sort. So no loose index scan, filter by key, group by, and the file sort. And this is significantly slower. This is 1.39 seconds. So our next topic is order by and file sort. So let's talk about let's start with a very simple example. So let's say that we need to find 10 cities in the United States with the largest population. So we have a city table again, and we do order by population. And we see here that there is no index used because there's no index, and MySQL is doing full table scan. This table is very small. There are only 4,000 rows, but still MySQL, as we see in the extra field of the explain output, MySQL is using file sort. So what we can do here is we can add an index. Again, we will add a covered index, combined index, and this combined index will cover our country code part and the population. As we can see now, MySQL will avoid using a file sort, so there will be no file sort here, which will be much faster. Another thing that we can potentially utilize is a specific MySQL feature that will allow to use an index on only the order by column. So this is how it works. I went back and used the on-time 2012 table. And as you can recall, it has the dep delay minutes field. I add a key on the dep delay minutes. It's just a single field. Now I do the explain of this particular query. I want to list all the flights with a maximum delay in 2012 and only cover the weekend. When I do this explain, I will see that instead of using a day of week field, or instead of using a covered index, it's actually used the depth delay minute. So why is that? What's the difference? The difference is limit. When I specify the limit 10, MySQL is smart enough to choose this depth delay minutes. Now, how does it work, and how MySQL is able to avoid creating a file sort and avoid doing the sort at all? So MySQL uses a specific algorithm here. Because index is sorted, we can scan the whole table in the order of the index. And then on top of that, we can filter result. We can remove the results that doesn't meet our condition. So we start reading this whole table in the order of the index and check for each row, does it meet our day of week condition? If it does, then we will keep this result. If it doesn't, we will discard this result, this row, and proceed to the next row. And then finally, we will stop after finding the 10 rows matching the where condition. This is very common case in the web applications where we want to display the latest posts, for example, or the latest entries, or latest something. So MySQL will be able to use an index on your order by field. Now, what about the performance? Will it be faster or slower? It actually depends. It depends upon where physically in the table those rows are. If we will be able to find those 10 rows pretty fast and only discard a fraction of our rows, then it will be very fast because it will be able to stop after finding 10 rows. Again, we have limit 10 here. This is what make it fast. But then if those rows will be physically at the end of the table or scattered around, and we will only find the first 5 rows that meet our condition, and then have to scan the whole table after that, then it will maybe even slower than doing the range condition on our where clause. All right, so the next and the last topic in this presentation is select distinct. This is actually a very interesting example, and this is based on the real customer story. I was helping customer to optimize one of their queries, and then I come up with this example. Now, the original customer didn't use this database, didn't use this table structures, but I was able to find a very similar example when working with a movie database. So let's say that we have a movie database, IMDb type of things, and we want to find the most recent movies that will also match our condition. So a developer will come up with this query, join 4 tables. And the reason for join is to filter out, because IMDb database, movie database, is highly normalized. Because it's highly normalized, we need to join to filter. Again, the only reason why we join these movie companies and company names and company type is because we want to filter out something. We want to filter out production year, we want to filter out kind, and stuff like that. Now, this will work fine, and the query is fast, but the result set may contain some duplicates. So someone complained about the duplicate entries on the web page. So how do we fix that? Well, we simply add distinct, right? So a developer added a distinct. And now for some cases, this query comes up really slow. So we now, another set of users start complaining about the speed. So what will happen in a typical web application? If the queries are slow, then the page load is slow. And the page will load for, in this case, 30 seconds. An average user will not wait. An average user will click stop on the browser and then do reload. Stop and reload, stop and reload, and then your MySQL server is filled with the queries that are performing really slow, and they can even fill up all your connections. So the new connections will not be accepted by MySQL because you reached max connections. So this is what happened in this particular case. Now, how do we fix that? How do we optimize that? So first of all, we need to do an explain plan. And what explain plan shows us is that MySQL will scan a lot of rows in this case. But what is even worse is that it will create a temporary table. Now, what we also found out is this is a very large temporary table. MySQL was creating a really large temporary table, and we were seeing this temporary table created on disk. Now, how do we profile that? The profile is actually easy. We can do a show status like created, run the query, and do the show status like created again. Now, in this particular case, we see that this query created a TMP disk tables. So it will create a temporary table right away. What we also notice is that no matter how large we set up our TMP table size or max heap table size, it will always create a temporary table on disk. Why is that? And the reason for that is that one of the fields, and I will go back here, one of the fields in the title is actually declared as a text description. So title description is declared as a text field. And this is why MySQL was not able to use a memory temporary table. We'll have to create a temporary table on disk. And you can imagine that if you have 50 of those slow queries hanging around inside of the MySQL, the performance will suffer and the disk temporary table will be really slow. So this is very hard case to fix. The best way to fix this is to actually denormalize the table. We can denormalize some of the fields and add those fields that we need to filter on into the main table, into the titles table. But there is also another way, is a hack. Again, I would not recommend that as a normal optimization. But it's also possible to do this. Instead of doing a distinct on the whole thing, we can actually create a we can create a subquery. And inside of this subquery, we only have 1,000 rows. Now, in this particular case, the distinct will be happening on the table that already filtered. So we do all the filtering inside of the subquery, then we do limit 1,000 that will only return 1,000 rows, and then we do a distinct to remove the duplicates from only 1,000 rows compared to 4 million rows originally. So as you can see, it will only, it is much faster. It returns our 10 rows that we are looking for in 0.02 seconds. Now, again, this is a hack, and it has another issue is that maybe there are lots of distincts there. Maybe there may be more than 1,000 distincts. So in this case, we will need to increase the limit originally in the subquery to overcome that. This is a possibility for a quick hack and for a quick optimization of this kind of query. Again, the best way will be to denormalize the original query, denormalize the original tables to include the fields that we need to filter on in our main table. All right, so this is all that I wanted to talk about today, and I will be happy to answer any additional questions. Thank you.
Hi, Alex. Can you hear me okay?
Yeah, I can hear you.
Okay, great. Audience, go ahead and ask any of your questions in the GoToWebinar panel in the questions window, and I'd be happy to ask Alex. And if we can't get to yours, we will definitely get to it in a follow-up blog post. Also, I just want to remind everyone that I will be sending a link to the recording as well as the slides, so you'll have that for your reference later. Okay, Alex, first question. Does MariaDB support covered indexes?
Yes, it does. Covered indexes is the feature that was available a long time ago, originally from, I don't even remember which version, even version 3, I think, was had that feature. And now what MariaDB also supports, I think, is they support the calculated fields, right? And I think that's what you meant. MariaDB does support the calculated fields, and they implemented this a little bit differently from what was implemented in 5.7.
Okay, next question. Are you programmatically issuing the alter, or are you forwarding the request to the DBA for temporary indexes?
So let me try to answer that. So, well, there can be two answers here. The first answer is a technical answer, right? So what we can always do alt table. And anyone who has a specific database access rights can do that. But it's maybe this question is more like less technical and more organization based. It depends upon the procedure. Some smaller shops do, developers do alter tables. Some larger organization has a DBA that is doing alter tables. You always need to be very careful with the alter table because it can lock the table and do some stuff in it, copy the table over. So we need to be very careful of how and when do we execute this alter table commands.
Okay, a little bit of a follow-up question, and I apologize if it's redundant. You know that I'm not as technical as you guys. So it is. You're using the alter table to create index to avoid temporary table in the explain of the query. But how does MySQL sort the data for creating the index? Isn't it using temp table for that?
Oh, that's a very good question. So MySQL has a number. Let's not say MySQL in this case. Let's say InnoDB because it's really up to the storage engine to create an index. So InnoDB originally before 5.6, before 5.5 actually, it was only be able to use one algorithm. So what it will do is it will create a new table with a new table structure, in this case a new table with a new index, and start copying the data over from old table to a new table. In MySQL 5.5 and 5.6, InnoDB is much smarter. If you're creating a secondary index, MySQL will be able to do a sort rows. InnoDB will be able to do a sort rows internally to create this index and append this index. So it will do all the table in place. It will not have to copy the table over.
Okay, the next question. Will I be able to upgrade to 5.6 or 5.7 when available on Debian 6?
Um, I'm not sure about, well, I'm not sure about the specific distribution, but yes, any Linux distribution will be available for upgrades. If there will be no package version, you can always do the just a binary version upgrade. So you can download MySQL or Percona server and upload it to your MySQL server and restart MySQL. Then you will need to follow the procedure, of course, how to upgrade from 5.5 to 5.6. But yes, it is possible and you can do that.
Okay, next question. Why is it that the covered index of the index contains only site ID but not ID when I need both site ID and ID?
Okay. So I think I understand what you're talking about. And please feel free to ask any follow-up questions here. But in your case, what happens is that you probably use InnoDB. If you're using InnoDB, then in InnoDB, you have a primary key, and this is what I think ID is. And any secondary key has a copy of your primary key in the index. So if you create an index on site ID and you have ID as a primary key, then you will already have both site ID and ID in your index. So you don't have to create an index on site ID plus ID.
All right, next question. Does the duplicate index found on 5.6 by 7 does that cause a performance impact to the database while querying?
Oh yes, we usually recommend to remove duplicate indexes. The reason for that is that it will obviously can hurt the performance of your write queries. Inserts, updates, deletes, they all need to update all the indexes. And this update will happen every time you do this operation. But also, if you have a lots of duplicate indexes, MySQL can get confused because MySQL will always choose to find an appropriate index for the query. And if there are lots of choices, then MySQL can start using your own index. So I would suggest using a tool called, it's a part of the Percona toolkit, the tool called PT Duplicate Key Checker. It will connect to your MySQL, find all the duplicate indexes, and create a report. And this report is actually a script. So you can run this script against your MySQL instance, and this will remove the duplicate indexes. Now, if you're using MySQL 5.5 and 5.6 with InnoDB, it will also be almost immediate. If you do alt table drop index, it will not have to copy the table over. It will just unlink the indexes.
Okay, great. Next question. If memory is available and the temp table size and heap size is increased to satisfy the query, will it be faster than optimizing the query?
Well, I would say that if you have a choice and you have the possibility of adding the current index or combined index, that will be much better way. Because table is slow by itself. Even the memory temporary table are slow. The reason for that, compared to the indexes, if MySQL will have to create a temporary table in memory, it will have to allocate its memory first. Second, to retrieve the rows, the temporary table, then it will be slower. So by choice, I would rather suggest.
Alex, I'm going to interrupt you. I know you're having problems with your headset. Can you stop moving your head? We're getting a lot of interference.
Okay, I'm sorry about that.
Yeah.
I'll try again. Yep.
Okay, perfect. Did you have more to say about that question, or should I go to the next one?
Yeah, I'm done with that.
Okay, thank you. What is the suggested method to measure performance on queries other than the slow query log so as to know where to create indexes?
So other than the slow query log, what we can do is we can use a performance schema in MySQL 5.6. So in MySQL 5.6, you can use the table called queries digest, which will show all the query, actually all the queries. And you can order by the query time, or you can filter by the queries that create template table and do file sort. So that will be your, if you're using 5.6, that will be your best bet to find the queries that needs to be optimized.
Okay, the next question is, let's see here. If a table has two columns you would like to sum, can you have that sum indexed as a calculated index?
Well, the calculated index, the calculated fields are only available in 5.7. And this is, as I mentioned, 5.7 is not ready for production yet. This feature is only available for preview, and you can download this version from the labs.mysql.com. It will be available in the future, though. So I hope that answers your question.
Okay, and we have time for maybe a couple more questions. So the next one is, let's see here. What would be the limit on index size or number of indexes you can define per table?
There are some limitations for every storage engine in MySQL, and you can view that on the MySQL website. You can search for InnoDB limitation. It will show you the exact numbers for the number of indexes and the limitation on the size of the field that can be indexed. But in general, you can you will not be able to index a text field by itself. You will need to specify the limit. So you can index the text field, for example, and you can specify the first 100 bytes out of the text field.
Okay, and the next question, what is the impact of collation sequence, if any, on query performance?
This is a very good question. So the collation can be problematic if you're mixing collation. So if you have something that is declared as UTF-8, but you compare that to non-UTF-8, or something like that, or different collations, if you're comparing different collation in a where clause, then MySQL may not be able to use an index. Other than that, if you're using collation consistently across the queries and the table, then it should not be a big issue. One possible issue is that when you use a collation, use non-Latin 1 collation, MySQL will have to create a larger template table. That's all.
Okay, we have time for just one more question. And audience, I will send all your great questions, and Alex, there's quite a few of them, to Alex after the webinar, and I'm sure he will get to posting a follow-up blog post to answer your questions. Okay, so the last question is, what is the performance impact of generating a virtual column for a table having 66 million records and generating an index? How would you go about this?
So again, the virtual indexes are only available in 5.7, which is not released. But as a general rule, it will be potentially better compared to the materialized field. But yes, if you have that number of fields, if you have that number of indexes, then doing alter table may be problematic because this is where the downtime can be. Other than that, I would say it may be worth it if you have a lots of queries that are accessing this. And you can optimize lots of queries by adding this feature. But what you will need to be careful about is how you perform the alter table. The alter table may be a bottleneck here.
Okay, thank you so much, Alex. That brings us to the top of the hour. Audience, thank you so much for participating in today's webinar. Alex, great job as always. And audience, I invite you to attend our next webinar on July 29th, which is going to be an introduction to MySQL sys schema. That should be a great topic too. And just a reminder, if you are planning on going to Percona Live in Amsterdam in September, the reserved room block is almost filled, so please go ahead and book your reservations very soon to get a space there. And with that said, again, Alex, thank you so much. And audience, we hope to see you again in a future webinar. Take care, everyone, and thank you again.
Thank you very much for listening.